This is Thevenin and Norton Equivalent Circuits, LabView Project by Ian Glover. Thevenin and Norton equivalents are a circuit analysis technique that we use in order to simplify things. As you can see in the picture, we start with a bunch of current sources, voltage sources, and resistors inside this black box going to terminals A and B, where we just want to find out what the general formula for what's inside that box is. So as you can see with a Thevenin equivalent, we turn that into one voltage source and one resistor. And with a Norton equivalent, we end up turning that into one current source and one resistor. Here's the circuit that I used to develop my Thevenin equivalent. Now there's a couple of important notes that I wanted to show here. First is, on the voltage source, I chose 9 volts. This is because with my DAC system, I would have two different ways to supply this voltage to my breadboard. The first would be through the 9-volt battery that is part of the breadboard, and the second is from the analog outputs from the LabView system. Now, this caused a pretty big problem while I was developing this lab. Originally, I didn't have that large 4K ohm resistor R1 at the front end of the circuit. What happened was, as I was trying to get the system to work, I wasn't getting enough current through my circuit to get the correct voltages. It turns out that there's a 2 milliamp current limiter in my DAC system, and there was just no way with the original circuit I had I was going to be able to get the appropriate voltages. This is why I added resistance into the circuit in order to drive the current needed down. Now, this is really probably the biggest thing I learned during this whole project, so I wanted to make sure this is a really key point to point out. So while building the circuit, just use basic fundamentals, make sure everything's grounded appropriately, pushed all the way in. For this system, you can see the orange jumper wire at the right. I used that for the load resistor because we're going to remove it to do all of our analysis during this lab. So to hook it up to the 9-volt battery, you can plug a jumper wire from the B plus slots over to R1 and B minus down to the ground line. And to hook the system up to the analog outputs, hook R1 up to the output 0 and the ground wire up to the analog ground. So in your block diagram, right click and go to Input, pick DAC Assist and put that onto your block diagram. Another screen will come up. You want to do Generate Signals, Analog Output, Voltage, and then AO0 and Finish. And then do Continuous Samples and hit OK. At this point, it'll put the DAC Assistant onto your block diagram. Then you can create a numeric control to put into that, and that'll allow you to control the voltage going into your circuit. To get the LabView digital multimeter running, go into your Start button, find the National Instruments folder, and find the Elvis MX folder. Launch the Elvis MX and select DMM on that box. Probably the most important thing when using the DMM in LabView is to make sure you have the correct range. For example, if you're measuring resistance on the scale of about 1,000 to 2,000 ohms, don't pick 20 mega ohms as your range. You will not get a valid value when measuring it. To measure my Thevenin voltage, I'm going to remove the jumper that's acting as my load resistor. I'm going to measure across R5 since there's no current going through R3. And I get about 1.39 volts. To get my Thevenin resistance, I'm going to short circuit where the voltage source is, and then measure the total resistance in the circuit from where the load resistor is. Doing this, I get about 2.07 kiloohms. Dividing my voltage by the resistance, I get about 0.6667 milliamps, but I'm going to measure it just to see how close it really is. So when measuring current with a DMM, I need to put the probe into the current slot just to make sure I do it correctly. I'm going to measure the current running through where the load resistor would be. And by doing this, I get 0.67 milliamps, so it agrees with my calculated value. So to wrap things up, let's go over the process of how to form an equivalent. So once I have my circuit, the first thing I want to do is open where the load is and measure the voltage across that. I short the sources and then measure the resistance, and short the load and measure the current. And lastly, I want to share my one important takeaway, and that's to understand the hardware limitations. As I mentioned earlier, I didn't know about the current limitations that I had with this system, and that caused me to be inefficient designing my circuit. It made me take a lot extra time than I really needed to. So, thank you. This has again been Ian Glover with Thevenin and Norton equivalents using LabView.